reflection, rotation, translation, and enlargement. A translation maps a point 1 to negative 1, 2. What would be the coordinates of the object whose image is negative 3, under the same translation? Now the first thing we have to find the translation vector. Here we shall subtract the image vector and the object's vector to get the translation vector. Now you can see I've subtracted the image vector negative 1, 2, object 1, 2. We get the translation vector as negative 2, 0. Now translate the image with the same vector. Now we have our image negative 3, using the same vector as 0, 2, negative 0, negative 2, 0. We have our object to be negative 1, 3, negative 3. Our object is negative 1, negative 3. A point negative 5, 4 is mapped onto point negative 1, by translation. Find the image of negative 4, 5 under the same translation. Now we also have to find the translation vector in this question. So we take the image vector minus the object vector. We get the translation vector to be negative 4, 5. Now translate the object using the same vector. We get that our image is at a point 0, 0. In the figure below, A or B represents part of a school badge. The badge has symmetry order of 4 about O. Complete the figure to show the badge. Now the figure was just this point O, A, B, C, D. That was the figure, the points that are named. So the points that don't have letters, the points I completed to make that figure to have a symmetry of 4. A triangle is formed by the coordinates of A, 2, 1, B, 4, 1, and C, 1, 6. It is rotated clockwise through 90 degrees about the origin. Find the coordinates of this image. Now you can see that triangle ABC. I've rotated it 90 clockwise, and you can guess it is giving the image at coordinates A prime as 1, 2, B prime as 1, negative 4, and C prime as 6, negative 1. You can do the same and you'll get the answer. My figure is not drawn to scale as such because it's system generated, but if you draw it on a graph paper or grade, you'll get the exact thing. Now a translation maps point P, that is 3, 2, and to point P prime, that is 5, negative 4. Determine the translation vector. B, a point Q prime is the image of the point Q25 under the same translation vector. Find the length of P prime, Q prime, leaving the answer in third form. Now you can see calculate the translation vector. You take the image minus the object vector, you get the translation vector as 2, -6. Now translating q with the same vector, we get q prime to be 4, -1. Now I've done that on the grid, and you can see I've sketched that point p prime, q prime. We have been told to find the length of that point. Now you can see if I drop those dotted lines vertically and horizontally, point p prime and q prime forms a right angle triangle. So on the x-axis, the distance is 1 unit. On the y-axis, the distance is 3 units. Using the Pythagoras theorem, if we square the x-axis distance plus the y-axis distance, we should be able to get the square of p prime, q prime. Now solving that, we get that the square of p prime, q prime is 10. Getting the square root, we get that the square of 10 is equals to p prime, q prime. We cannot solve further because we have been instructed to leave the answer in a third form. In the figure below, triangle A prime, B prime, C prime is the image of triangle ABC under a rotation center O. By construction, find and label the center O of the rotation. Now, what we need to do here is to join any 2 points, like B prime. I join B prime to B just with a straight line. Join B prime, point B prime and B, and then using a compass, bisect that line B prime B, and then join the other point like A prime and A, and then bisect that point. Now those bisectors, where they meet, it will be the center O. Now join any of the points like B to B prime to O, and then O to B. Measure that angle. That will be the angle of rotation. Now if you do so, you get an angle of 60 degrees. The diagram below is part of a figure which has a rotational symmetry order of 4 about O. A. Complete the figure. B. Draw all lines of symmetry of the completed figure. Now that diagram had only one part that looks like a kite with a triangle in it. So the other 3 parts I've drawn to complete the diagram, and then the dotted red lines I've inserted there to show the lines of symmetry of the completed object. On the Cartesian plane below, a triangle PQR has vertices P 2, 3, Q 1, 2, and R 4, 1. While triangle P prime prime, Q prime prime, and R prime prime has vertices P prime prime -2, 3, Q prime prime -1, 2, and R prime prime -4, 1. Describe fully a single transformation which maps triangle PQR onto triangle P prime prime, Q prime prime, R prime prime. And then see, describe fully a single transformation which maps triangle P prime, Q prime, R prime, and to triangle P prime prime, Q prime prime, and R prime prime. D. Draw triangle P prime prime, Q prime prime, R prime prime, such that it can be mapped onto triangle PQR by a positive quarter turn about 00 or 00. C. State all pairs of triangles that are oppositely congruent. Now, part A, the transformation of PQR onto P prime prime, Q prime prime, and R prime prime, you can clearly see that it's a reflection in the x-axis. You look at those triangles, you can see I've done that line about 00 as dotted. You can see it's a reflection. It's like a mirror. PQR has been reflected to P prime prime, Q prime prime, R prime prime. Now B, you can clearly see I've drawn that triangle P prime Q prime as a reflection, and the line I've dotted y is equals to negative x. I've clearly indicated the line and the key. You can see it is dotted with it's a red dotted line, so it is reflecting the image PQR as P prime Q prime R prime. Now part C, now a transformation that maps P prime Q prime R prime onto P prime prime Q prime prime R prime prime. You can guess it's a negative 90 turn about the origin 00. Just look at it clearly. It's a negative turn, a quarter negative turn. Now part D, you can see I've clearly drawn that, and you can see the coordinates of P prime prime 3 times prime is 3 times is 3 negative 2, and then Q prime 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 is 2 negative 1, and R prime 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 is 1 negative 4. Now lastly, state all pairs of triangles that are oppositely congruent. I've named them. You can see PQR and PQR, P prime QR, Q prime R prime, and P prime prime, Q prime prime, R prime prime, and lastly P prime prime, Q prime prime prime, and then R prime prime prime. Those triangles, those 3 triangles, those four triangles are negatively congruent. The others are P prime, Q prime, R prime, and P prime 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 3 times, Q prime prime prime, R prime prime, PQR, and P prime prime, Q prime prime, R prime prime. I've written there. If I'm pronouncing badly, just look at what I've written. The diagram below shows a triangle ABC with A 3, 4, B 1, 3, and C 2, 1. Draw triangle A prime, B prime, C prime, the image of ABC and a rotation of 90, positive 90 degrees about the origin. Draw triangle A prime prime, B prime prime, C prime prime, the image of triangle A prime, B prime, C prime, and a reflection in the line y is equals to x. Draw the image A prime prime prime, B prime prime prime, C prime prime prime, the image of triangle A prime prime, B prime prime, C prime prime, and a rotation of -90 about the origin. Describe a single transformation that maps triangle ABC onto triangle A prime prime prime, B prime prime prime, C prime prime prime. E. Write down the equation of lines of symmetry of the quadrilateral B, 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 and then B prime prime, A prime prime prime, and A prime. Now you can see I have drawn. I use the system to draw, so that's automatic. If it has distorted somewhere, you can draw them on a grid, and you'll come up with the thing. I think I cannot explain further the previous diagram. Now let's look at this one. In the figure below, ABCD is a square. Points P, Q, R, and S are midpoints. A, B, B, C, and C, D, and D, A, respectively. Describe fully a reflection that maps triangle QCE onto triangle SDE. An enlargement that maps triangle QCE onto triangle SAE. A rotation that maps triangle QCE on triangle SED. The triangle ERC is a reflection on the line BD. The image of ERC under the reflection is rotated clockwise through an angle of 90 degrees about P. Determine the image of R and C under the reflection out of the two successive transformations. I think that is easy to do, and it will be prudent if you do it practically. I've written the answers alongside the square, though you can see that the system has distorted it. It doesn't look like a square, but you can draw it. You can draw it the way it is and try to appreciate the question. The vertices of triangle are A 1, 2, B 3, 5, and C 4, 1. The coordinates of C, the image of the coordinates of C prime, the image of C, and the transition vector T are 6, -2. Determine the transition vector. Find the coordinates of A prime and B prime under the transition vector. So the transition vector, we shall take the image minus the object to get the transition vector of 2, 3, and then let's translate by adding to the object, to the image A prime, B prime to get the object. So we get 3, -1, and 5, 2. The vertices of a quadrilateral OPQR are 0, 0, P20, Q42, and R03. The vertices of its image and the rotation and a rotation are O prime 1, negative 1, P prime 1, negative 3, Q prime 3, negative 5, and R prime 4, negative 1. So A, 1. On the grid provided, draw O, P, Q, R and its image O prime, P prime, Q prime, and R prime. 2. By construction, determine the center and the angle of rotation. B. On the same grid as A1 above, draw O prime prime, Q prime prime, R prime prime, the image of O prime, P prime, Q prime, and R prime, and a reflection in the line y is equals to x. C. From the quadrilateral drawn, state the pairs that are 1. Directly congruent, 2. Oppositely congruent. Now you can see I've drawn clearly and given the answers alongside. This one will appreciate by drawing the on the grid provided. Draw the square whose vertices are 6, negative 2. That is for A, and B 7, negative 2, C 7, negative 1, and D 6, negative 1. On the same grid, draw A prime, B prime, C prime, and D prime, the image of A, B, C, D, and an enlargement scale factor of 3, center 9, negative 4. 2. A prime prime, B prime prime, C prime prime, D prime prime, the image of A prime, B prime, C prime, and D prime, and a reflection in the line x is equal to 0. And then 3. A prime prime prime, B prime prime prime, C prime prime prime, and D prime prime prime, the image of A prime prime, B prime prime, C prime prime, D prime prime, and a rotation of positive 90 about the origin. Describe a single transformation that maps A prime, B prime, C prime, and D prime onto A prime prime prime, B prime prime prime, C prime prime prime, and D prime prime prime. Now you can see I've clearly drawn and labeled everything and given the answers alongside. So try it yourself. This one you can appreciate by drawing. Now points A are 2, negative 2, 2, and B, negative 3, 7, are mapped onto A prime 4, negative 10, and B prime 0, 10 by an enlargement. Find the enlargement scale factor. Now you can see I've tried to draw those points like point A and B. I've drawn and joined them with a blue color, and then point A prime, B prime, I've drawn and joined them with a brown color. Now look at point A, B prime. Point A, B prime is between point negative 3 and negative 2. That's just 1 unit in between. Now look at point A prime and point B prime. Point A prime and B prime is between, on the x-axis I mean, is between 0 0 and 4. Those are 4 units. So if you compare point A, B covering only 1 unit on the x-axis, and point A prime and B prime covering 4 units, it means that the enlargement scale is 4. 1 unit has been enlarged by 4 units. On the grid below, an object T and its image T prime are drawn. Find the equation of the mirror line that maps T and T prime. B1, T prime is mapped onto T prime prime by positive quarter turn about the origin. Draw T prime prime. 2. Describe a single transformation that maps T onto T prime prime. T prime prime is mapped onto that C. T prime prime is mapped onto T prime 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 by an enlargement center to 0. Scale factor -2. Draw T prime prime prime. Given the area of T prime 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 is 12 centimeter squared, calculate the area of T. Now you can clearly see I have done that. I use the computer to do that automatically. So my workings are hidden inside. But now the results I have given alongside for A, B1, B2, C, and try it and see if you get the same results I have gotten. A triangle T with the vertices A 2 4, B 6 2, and C 4 8 is mapped onto a triangle T with the vertices A prime 10 0, B prime 8 -4, and C prime 4 -2 by rotation. On the grid provided, draw triangle T and its image. Determine the center and the angle of rotation that maps T onto T prime. You can see I've drawn the triangles, though the image has been distorted a bit by the automatic cell the computer gave me, but you can see you have the idea. Now the center of rotation is 4 -2, and the angle is 90. A triangle ABC has vertices A -2 2, B 1 -1, C -1 4 is mapped onto triangle A prime B prime C prime by reflection in the line y is equals to x plus 1. A. On the grid provided, draw triangle ABC. That's A1. A2, the line y is equals to x plus 1. And then A3, triangle A prime B prime C prime. And then B, triangle A prime prime B prime prime C prime prime. And the image of triangle A prime B prime C prime and a negative quarter turn about the origin. On the same grid, draw triangle A prime prime B prime prime C prime prime. And then C, state the type of congruence between triangles 1. A, B, C and A prime, B prime, C prime. 2. A prime, B prime, C prime and A prime prime, B prime prime and C prime prime. Now you can see I've drawn, which is very clear. I will appreciate if you try to draw it and see if you find the same results I've written about grade. The figure below shows a quadrilateral ABCD and a mirror line M1, M2. Draw quadrilateral A prime, B prime, C prime, D prime, the image of A, B, C, D, and a reflection in the mirror M1, M2. State the type of congruence between the A, B, C, D, and A prime, B prime, C prime, D prime. Now, I'll give you directions how to draw the image. What you have to do is you have to drop a perpendicular from A, B, C, D through M1, M2. Now, then ensure the distance from points to the mirror line from the of the image and the objects are the same. And then join A prime, B prime to C prime to D prime. After I've done that, you will replicate the same image that is just inverted vertically. So the type of congruence is indirect opposite. Complete the figure below to show rotational symmetry order of 3 about the origin. Now here we are given one flag, just one flag. You can see a post and a flag. So I've drawn the other two to show a rotational symmetry of 3. I hope every flag is if you take 360 divided by 3, the angle between should be that angle. 360 divided by 3, 120 I think. Now try to draw such like a thing. It may not be to scale, but at least you get the idea. Triangle ABC and A prime, B prime, C prime are drawn on the grid provided. Describe fully the transformation that mapped triangle ABC onto A prime, B prime, C prime. On the same grid, draw triangle ABC, the image of triangle ABC and a rotation of 90 degrees about the origin. Triangle A prime prime, B prime prime, C prime prime, the image of A prime prime, B prime prime, C prime prime, and a reflection in the line y is equals to negative x. Draw the line of symmetry of the triangle A prime, B prime, C prime, and hence determine its equation in the form y is equal to mx plus c, where m and c are constants. Now you can see I've clearly drawn that, though distorted a bit by the computer which gave an automatic scale. But if you draw on the grid, you get the clear thing. That's a guide that you should not have any problem doing that. Now the line, if you took two coordinates and found the line the way we find the equation for straight line, you should be able to get it as y is equals to negative a third x minus 4. On the following grid, triangle PQR is drawn. On the same grid, draw one triangle PQR, the image of triangle PQR and a reflection in the line y is equals to 0. Triangle P prime, Q prime, R prime, the image of triangle P prime, Q prime, R prime, and an enlargement scale factor negative 1.5, center of origin. 3. Triangle P prime prime, Q prime prime, R prime prime, the image of triangle Sorry for that. I've repeated 3. So I was on B. B. Describe a single transformation that maps triangle P prime, Q prime, R prime, and triangle P prime prime, Q prime prime, R prime prime. Now you can see I have clearly drawn that, and I'm sure it is easy to follow. Drop any query in the comment section. I tackle it.